As you can see from the results, we looked at the key indicator compounds that Con had recommended, the guaiacol, 4-methyl guaiacol, and also we looked at 4-ethyl guaiacol, 4-ethyl phenol and furfural. So we're looking at a range of compounds that had been routinely detected in wines before. And as you can see from those wines produced from smoked grapes, the levels of these compounds were extremely high. So we proved our cause and effect. You apply smoke to grape bunches, you're going to get heavily smoke-tainted wines. There was no detection of these compounds within wines made from grapes that were not exposed to smoke. We also looked at the aroma threshold of this smoke taint in wine. We used people who were wine consumers to detect the aroma. We initially conducted some difference tests, and we found that 99.9% of consumers could detect the difference between smoked and unsmoked wines. With the aroma threshold, we found that to be quite low, 3.88 mils, which corresponds to a dilution of 1.6%. So that's really quite low. We also found from our chemical analysis that the levels of guaiacol and 4-methyl guaiacol in the aroma threshold were well below those that had previously been published. The guaiacol equated to 23 micrograms per litre, so for a white wine that's quite a ways below the published threshold, and the methyl guaiacol was 5 micrograms per litre, which is also right below the previously published threshold. We found that participants described these wines as smelling smoky, dirty, earthy, a lot of smoked meat characters, salami type characters, and they also smelt burnt. Through all our research, we've only conducted aroma analysis. We haven't got participants to actually drink the wine. I don't know if there's any health concerns with drinking smoke-tainted wine and carcinogens and everything else, so it's only aroma analysis. Our next lot of research really wanted to take the smoke application out into the vineyard to apply smoke to field-grown grapevines. We were looking at the influence of phenology on the smoke uptake, and also furthering looking at the fermentation process and conducting some further sensory analysis with these wines. As I probably mentioned before, this is a key point of difference with our smoke taint research in the sense that we're applying smoke directly to vines. We also have a control treatment which makes it quite good for comparison. We have applied the smoke in the field for the past 3 years, and we have proven our methodology in doing so. It's been a bit of a trial and error kind of thing, and it hadn't been achieved before, so we have been able to create a smoke taint effect. Some of you have probably also seen these slides which show our field application of smoke. Basically what we have constructed is just a simple network of field tents. These tents are about 2.5 metres high and 6 metres long, and they're designed to enclose the grapevines within so that smoke can circulate around the grapevines. The tent cover is made of a greenhouse grade plastic called solar weave, which enables the transmission of light through to the grapevines to enable the grapevines to continue to photosynthesise whilst they're in the tent as much as they can with smoke application running around the tent. We also have a smoke generator. This is an older version model of our smoke generator, which is basically just a drum in which we put fuel within the drum and we ignite the fuel. We have a series of pumps which we pump air into the bottom of the drum, and the smoke is pumped out of the outlet tube into the tent. We also use some smoke monitoring equipment. At our last presentation over here in Victoria, it was recommended that we use nephelometer type equipment. David recommended that, so we've been using that since that time and working closely with VESDA nephelometer suppliers to make sure that our smoke application is true. What we did with our initial smoke application in the vineyard was we applied smoke to grapevines from the period of veraison through to harvest. So the 0 here on this graph represents veraison and so many days towards harvest. What we found was we were able to create a smoke taint effect within the wines, and we also found that there was a peak period of sensitivity to smoke at 7 days post veraison. This top line here represents the guaiacol level in the final wines, and we also have the 4-methyl guaiacol and the 4-ethyl phenol level. We have also since taken this research through and applied smoke at other growing stages throughout the grapevine cycle. We've conducted that particular work over 2 years just to make sure that we're correct in determining what timings of smoke exposure are conducive to smoke uptake and development in wine. Through our initial veraison to harvest smoke applications, we had one treatment where we applied smoke to that same treatment 8 times over that period. And what we found with this treatment was that the smoke taint compounds had a cumulative effect in wine. So the more exposures that you have of smoke to the grapevines, the higher amount of smoke-like taint compounds you are likely to find in the wines. We also found that there was an increase in fermentation rate from grapes that were exposed to smoke, and we have found this in all of our smoke treatments. In comparison to the control, if you apply smoke to grapevines or you're making wine out of smoky tainted grapes, you have an increased fermentation rate. We also found, and as did Con find in his research, that there was an increase in concentration of compounds throughout the fermentation process. I think Con also mentioned that there can be less glycol in pressed juice. Yeah. We had a pre-pressing analysis done on the wines post-pressing, which was a little slightly lower, not significantly different, but a little slightly lower. And we had the level detected in the grape mark, and this level was quite high in the final wines. And Kerry Wilkinson will be discussing this further in her presentation, and also looking at the wines 1 year post-bottling, which will be interesting for what Wendy was talking about before. We also conducted a quantitative descriptive analysis with these wines with a trained sensory panel. The sensory panel indicated aromas of burnt rubber, smoked meat, leather, disinfectant and hospital aromas in the smoked wines, and more confection and red berry fruit characters from the unsmoked wines. I don't know if I mentioned before, but this research was conducted on Merlot variety. As you can see from this cobweb plot, the red depicts wines that were made from fruit exposed to repeated smoke applications. And as you can see, these are really highly elevated in these smoke-like characters, with the control wines made from unsmoked grapes being high in the confection and red berry fruits. So it's quite significantly different. We also wanted to address the issue of smoke carryover from year to year, which had also been a question raised by industry. And what we found that the 1 year post repeated smoke application had a low level of smoke taint-like compounds within the final wines. So there was a limited amount of carryover, or no carryover really. There was just a low level of guaiacol found within the wines 1 year post-smoke application. We also conducted some sensory analysis on these wines to see if there was any other aromas that were depicted 1 year post successive smoke applications, and then we found there to be no significant difference. So therefore there was really no real carryover of the smoke taint effect. What we found was the main carryover of the smoke taint effect, which was really quite interesting, was that there was a reduction in yield. 1 year post-repeated smoke application resulted in a yield of 6.4 kilograms in comparison to the control, which was about 20 kilograms. The bunch number was also significantly decreased 1 year post-smoke application, and also what we found was the shoot growth was significantly different as well, and that was quite a visible effect. It was a lower shoot length.